You know that feeling of sitting perfectly still? Turns out that's one of the biggest illusions there is. The truth is, you're on an absolutely incredible high-speed journey through the cosmos. So let's break down just how fast you're really moving. We're about to dive into the speeds you're hitting right this very second, without even feeling a thing. And trust me, these numbers are staggering. So let's start with the motion that's happening right under our feet. Okay, first up, 1,600 kilometers an hour. That's how fast the Earth is spinning if you're standing on the equator. So why don't we all feel like we're on a cosmic merry-go-round? Well, it's because everything, the air, the oceans, you, me, is moving right along with it. It's our constant, shared speed.
But hold on, because that's just the beginning. As the Earth spins, it's also whipping around the Sun at a blistering 30 kilometers per second. To put that in perspective, at that speed, you could cross the entire planet in just a few minutes. That relentless pace is what defines our year.
And it doesn't stop there, not by a long shot. Our entire solar system, the Sun and all its planets, is rocketing through the Milky Way at a mind-bending 230 kilometers per second. It takes us about 230 million years just to make one trip around the galactic center. We are all on one heck of a cosmic carousel.
So here's the key takeaway. Absolutely nothing is fixed. You know those star patterns in the night sky? They feel ancient and permanent, but they're not. Every single star is moving. And over enough time, familiar shapes like the Big Dipper will warp into something completely unrecognizable. The universe isn't some static picture. It's a dynamic, living system.
All this motion just begs a huge, fundamental question. This can't all be random chaos, right? There has to be a reason for all this spinning and orbiting. So why? Why isn't the universe just still?
And this is the central mystery. On one side, you have gravity, this immense force, constantly trying to pull everything together into one big clump. But on the other side, you have this relentless motion. So what's keeping everything in this beautiful, delicate balance? The answer, it turns out, is one of the most elegant principles in all of physics.
Let's introduce the hero of our story, angular momentum. This single, simple law governs everything from a spinning top on your desk all the way up to the formation of entire galaxies.
To put it simply, spin doesn't just vanish. Once something starts rotating, it wants to keep rotating. It's kind of like rotational inertia. And this very principle, that motion is conserved, is what creates that illusion of stillness we feel every single day. The motion isn't lost. We're just part of the system. The perfect way to picture this is with a figure skater. You've seen this a million times. They start a spin with their arms stretched out nice and slow. Then they pull their arms in tight and whoosh, they suddenly speed up into a blur. No one pushed them harder. All they did was concentrate their mass closer to their center. To conserve that initial spin, their speed had to increase. The universe does the exact same thing.
So, a figure skater makes sense. But how does that one simple rule create the entire universe we see around us? Well, let's take that law and apply it on a cosmic scale.
Billions of years ago, our solar system was just a giant, lumpy cloud of gas and dust. As gravity started pulling it all inward, any tiny, random bit of rotation it had got amplified, just like our skater pulling in her arms. The cloud spun faster and faster, flattening into a disk. The sun ignited right in the center, and the planets formed from all the leftover material in that spinning disk. That's why all the planets orbit in roughly the same direction and on the same flat plane. It's like a fossilized record of our solar system's birth. And this motion literally shapes worlds. Earth isn't a perfect sphere, you know. Its constant rotation causes it to bulge out at the equator. It's about 43 kilometers wider there than it is from pole to pole. It's a subtle difference, but it's a permanent physical reminder that we live on a spinning ball. And this is where it gets even more fascinating. Because spin isn't just about explaining the things we can see, it's also our best tool for detecting the things we can't. So when we look at galaxies, we see stars on the outer edges moving way too fast. Based on all the visible stuff we can see, the stars and gas, there isn't nearly enough gravity to hold onto them. They should just fly off into space. The fact that they don't tells us there has to be something else there, some invisible mass providing extra gravity. We call it dark matter, and we only know it exists because we can see how it affects a galaxy's spin.
And when you combine mind-boggling gravity with angular momentum, you get something like a neutron star. Imagine packing more mass than our sun into a sphere the size of a city. As the original star collapsed, all its spin was conserved and magnified, causing some of these things to rotate hundreds of times per second. They're so precise, they're like perfect cosmic clocks.
And this isn't ancient history. Right now, missions like the Gaia Space Observatory are meticulously charting the positions and movements of over 1 billion stars. By tracking their motion, we are literally watching the story of our galaxy unfold in real time, mapping its structure, and seeing gravity and spin at work.
Okay, so let's take one final giant leap. We've seen spin create galaxies and solar systems. But what if I told you that this principle goes all the way down to the fundamental nature of matter and even time itself?
That's right, every fundamental particle, electrons, protons, quarks, has a quantum property we call spin. It's not exactly like a tiny spinning ball, but it's a fundamental built-in angular momentum. This tiny property governs how atoms form, how chemicals bond, basically how all matter in the universe is structured. Spin is literally written into the fabric of reality.
And this is why our concept of time is inseparable from motion. I mean, what is a day? It's one full spin of our planet. What's a year? It's one orbit around our star. Even our most precise measurement, the atomic second, is defined by the repeating cycle of an atom buzzing with energy. Time, as we measure it, is just the rhythm of cosmic motion.
So here's the bottom line. Without spin, without angular momentum, the universe as we know it simply couldn't exist. There'd be no flattened galaxies, no orbiting planets, no stable solar systems. Gravity would have just pulled everything into still, silent spheres. Motion is the architect of the cosmos. And that leaves us with one final thought. Every rotation, every orbit, from the smallest atom to the largest galaxy, is part of a grand cosmic dance. We are all passengers on a spinning planet, in a spinning solar system, in a spinning galaxy, all moving together. The universe isn't just going somewhere, it's turning. And with every single turn, it's carrying us into the future.